In early 2009, Iran's secret program to build nuclear weapons suffered a series of mysterious setbacks. Centrifuge machines used to purify uranium suddenly spun out of control and tore themselves apart. More than 1,000 machines were destroyed, and Iran's pursuit of nuclear weapons was seriously delayed. Only years later was it revealed that the machines had been destroyed by a computer virus called Stuxnet, a malware so sophisticated that it could only have been developed by state-level threat actors. In this case, almost certainly a partnership between the United States and Israel. The attack was a wake-up call for the cybersecurity industry. It demonstrated that hacking attacks aren't only limited to damaging or taking control of computer systems, but also reach through those systems to create physical effects in the real world. Of course, that was surprising then, but now we live in a world in which planes are routinely sent off course, power distribution systems are shut down, and hospitals are paralyzed, all as a result of cyber vulnerabilities being exploited. There's now a whole subspecialty of the cybersecurity field called cyber physical, devoted to just this kind of attack. And I'm fortunate to have with me today one of its leading lights. Dr. Krishna Sampigethaya is a professor at Embry Riddle Aeronautical University who will talk to us about its relevance to aviation and specifically to MH370. I'll ask him whether, in his view, MH370 could have been the victim of a cyber physical attack. Hi, everybody, and welcome back to Finding MH370, the investigative podcast into aviation's greatest mystery. Before we get to Dr. Sampigethaya, a quick housekeeping note. Our Kickstarter, the Finding MH370 project, has sadly expired. We had set an ambitious goal to raise $50,000 to buy, modify, and deploy a real 777 Flapron into the Indian Ocean, and unfortunately, we were not able to reach it. We did get over $3,000 pledged by 38 backers, and I'm deeply grateful to everyone who lent their support. Even though the Flapron will not be launched, the other half of the project will continue, that is to gather LEPUS data from drifter buoys. So we will continue that apace, and you'll hear all about it in upcoming episodes. And now let's get on to the main event. Dr. Krishna Sampigethaya is chair in the Department of Cyber Intelligence and Security at the Embry Riddle Aeronautical University in Prescott, Arizona. He received his PhD in electrical engineering from the University of Washington in 2007 and was one of the first in the world to defend a thesis on connected vehicle privacy and aviation cybersecurity research. After receiving his degree, he joined Boeing, where he was named the first Boeing Associate Technical Fellow for Aviation Cyber-Physical Security in 2012. So as such, he is one of the most knowledgeable people in the world about the cybersecurity of Boeing airliners, about the current threat environment, and how to mitigate the risks that civil aviation faces. Let's get right into it. Let's just jump right into it because you have so much knowledge. I wanted to ask you to start a little bit about your career. I've spoken to you once before. I interviewed you for a Vanity Fair article, which still hasn't come out, by the way, but that's typical. But I asked you, like, how did you get into this? You were so ahead of the curve, because I feel like what you study is very of the moment.
Thanks.
And you've been doing it for a long time. You were one of the first people to write a dissertation on basically aviation cybersecurity.
Right. I think it's the timing of it was, I think, probably the reason why it came out that way. Back then, both the automobile and the aviation industry were trying to get connectivity into the vehicle platform. Ford was doing it with the sync system that was then being explored in the broader context of vehicular networks. So it was vehicle to vehicle and vehicle to infrastructure communications. So there was a lot of that going on, but also the Boeing was also doing the e-enabling of the aircraft. The e-enabling means you're going to make more and more networking and software and computing into the aircraft itself. And so it was really the timing of it that they had all these technologies coming into the vehicular platform and not much security and privacy considerations. And so that was when I was able to research into that area and publish a or defend a dissertation on the topic.
So you were, this was around like 2008, kind of late 2000s.
No, it was actually as early as 2005,
Oh,
so
wow.
almost 20 years ago.
Wow.
2005 to 2006, 7 is when it was all being introduced into the both automobile and the aviation
And so
sector.
Boeing at this time was working on the 787, is that right?
Yeah, that was being rolled out back then.
They were
The
being rolled out. So they'd
787.
already designed it.
Right. So that is the first E-enabled aircraft. That's what we call it.
Okay.
So that was one of the first that came out with the different types of connectivity that did not exist with the other aircraft before.
So one thing I think would be useful to point out is that if you go to an airport and you look out the window of the
Yeah.
terminal and you see these airplanes rolling around, a first generation 737 doesn't look too different to the untrained eye from a current one. They've got two engines under the wing and they've got a conventional tail and they're a tube. But there's a big difference actually between the first generation 737, which was actually um, push rods and mechanical linkages,
Sure.
and the current generation of aircraft, they're the latest ones, which are not only fly by wire, but heavily interconnected. You've got wireless communications, Wi-Fi, all kinds of, thousands or tens of thousands of computerized systems on board a plane. The
Right.
complexity is vast, and there's a lot of surface area if you look at it from a
Yeah.
cybersecurity standpoint.
Right. Yeah, and that's why it became important. So FAA and Boeing worked way back then. I think 2006, 2007 itself. They were looking at how do you analyze new types of threats that come
Okay.
to the aircraft because of this expansion of not just the technology area but also the threat surface itself has expanded. So how do we look at these new threats? That's when they put out these special conditions which require a threat analysis that
Okay.
is done and mitigations put in place.
Because for years, I mean, since the Wright brothers almost, aviation has been focused, especially commercial aviation, has put a very serious priority on safety. And
Yeah.
this has meant making sure that your metallurgy is good, that your systems are designed for human factors,
Hmm.
that people won't, fail or push the wrong button, that the wings won't fall off, and so forth. And that's all under safety, and that's what accident investigation is all about. Sort of retrospectively trying to make sure that whatever bad things happen won't happen again. But then, as planes become more cyber enabled, more computerized, more automated, you're making systems that maybe defy the traditional way of doing things because you've got complexity that can can a break in unexpected ways, but also be attacked in unexpected ways.
Right, that is true. I mean, that's why the airplane is now really a system of systems, right? So you have
Mm.
the whole aircraft, but you have all of these different cyber enabled, like you said, systems that interconnect and make the airplane fly in the air and reach wherever it needs to go. Uh, that's why it became important that they come together as a committee, which is what I think I mentioned to you, the RTCA is a body that helps the FAA to kind of regulate and guide the industry.
Okay.
They came together way back and started putting together all these different stakeholders who have different parts of the aircraft to operate their own systems in. And so they came together and started looking at how do we do this? How do we uh, certify not just safety, but the safety relevant security threats back then. And so they have been working on it and have released documents as the updates were needed. But as you know, technology is much faster. And so there's still some gaps that need to be continuously addressed. And that's the reason why it's so difficult to do as a large body of stakeholders in the aircraft.
Yeah, and one of the themes that we keep returning to in this podcast is the balance between security and safety. So,
Mhm.
an example, I know that you worked on this, and there was a paper that cited your work,
Okay.
about the vulnerability of ADSB, where
Mhm.
you have a system that is wide open. It was kind of intentionally designed to be wide open,
Right.
unsecured. Anybody can jump in there. And that's intentional because we want everyone to be able to trade information freely. But
Mhm.
if you make so that they can see where each other, everyone can see where they are, so they don't collide it,
Yeah.
among other things. There's a trade-off. There's an inherent trade-off that maybe people might not be aware of, which is that in having a free and open, means of exchanging information with one another, you also open up the vulnerability to potential bad actors.
Right. Yeah. And that is true. I mean, the ADSP, I think the way to look at it is there are two modes. So there is the mode where you are sitting on the ground, you have a network of stations on the ground, they collect ADSP data and they put it together as a picture for the air traffic controller to see and say, okay, I have my radar reading, I have my ADSP reading. If they don't correlate, there's something that's off. That's kind of where they felt there is a net, a safety net really to look at. But as you keep removing the radar, or rather, downgrading the amount of data from radar that you're collecting, then you have a data point that you have to really trust and say that that's essentially where the aircraft is. And that's where the whole community is saying that, oh, ADSP has no encryption, it's got no authentication. How do we then know that this data point that's coming on the air traffic controller screen is actually trustworthy? And so FAA has looked at using alternative surveillance technologies to fuse the data together and then only present it to the air traffic controller.
Oh, really?
Yeah, so
So
that is
they're basically verifying the information that's coming in from an unsecured.
right. It's called multilateration. That's one technology. So they're using the timing and the arrival of the signal to different stations to then essentially say, okay, this data point makes sense. Let's put it through, right? And then there's this whole telecommunication network that brings all the data to a center where it is then essentially processed and presented to the air traffic controllers. So then there's a whole air traffic control architecture there that takes this data. However, there is the whole need for cyber physical resiliency, which I mentioned. That is the area where you cannot just rely on that as enough. You need
Mm-hmm.
more. And so that's where you can bring in, if there are going to be humans involved in that, which is air traffic control in that context, then you need them to be prepared for scenarios where the data may not be actually a valid one. It might be a bogus data that's been injected, not necessarily over the air, but injected into the network or through the software that's operating at different systems that go to the air traffic controller. Then you need to be able for them to detect there's something going on. Then how do you then go about mitigating that threat? Is it to train the air traffic controllers, or maybe do that and introduce machine learning or some other technology to detect these kind of introduction of malicious messages? So these
Right.
are things that are where the cyber physical resiliency comes in for the ADSP on the ground. And if I can add now, ADSP on the aircraft. So other aircraft receive directly ADSP messages
Right.
and they present the pilots with, hey, this ADSP data indicates that airplane is this much away from you and it's at this particular position and it's moving at the speed and direction. So all of that is again plain text. There's no encryption or authentication. Hence, there is a delay as to what do we really use that data for? Can it be a safety critical function? No, it cannot, because there's no security for that kind of ADSP message based applications. There's a whole.
Maybe I could explain to listeners who might not be familiar
Oh,
with this
yeah.
technology that, for instance, I'm flying in my plane, and my automated system, which is called ADSB, is transmitting not only to the ground where it's picked up by air traffic control, but is transmitting directly to your plane. You have an automated system that is receiving this information about where I am, and under certain circumstances, one of the systems that this system is connected into is called collision avoidance, right?
Yes.
And so your plane might say, "Pull up, pull up, pull up," or some other kind of command.
Yeah.
And if you're in a critical phase of flight, maybe you're on short final or something, and it could be distracting. It could tell you to do the wrong thing. It's a potential real serious safety issue.
Right. And that's where I'm saying that they have not enabled that yet. So,
Okay.
in my opinion, that is a less, more reduced or a less performing version of ADSP that's being used on the aircraft
Okay.
because there is no security built in into that transmission from other aircraft to aircraft.
Right.
TCAS is the only one right now that is using that air-to-air message based collision avoidance system. But even that has been problematic. Recently, there was a TCAS related, it's called a resolution advisory, which
Okay.
essentially does climb, stay, or go down. It's like a single dimension movement, and that led to actually injuries on the aircraft because it,
Wow.
yeah, so it has happened very recently, and that is TCAS, not ADSP. Now
So
there is
that,
that.
just to be clear, that was not a cyber
Mhm.
attack
No,
issue. That was a system that was functioning as it was built, but it was just actually
right.
unfortunate the way it worked out.
Right. There is a residual risk right now, which, as you know, is leading to news such as air traffic controller not being able to manage two aircraft that are possibly in a collision path. There is also the fact that TCAS, like I said, has these spurious signals that lead to resolution advisory or a traffic advisory that may not be genuine, or there's a conflict between ATC and TCAS advisories, which has led to problems before. These are
I see.
residual risks without cybersecurity or without cyber attacks in there. And
Okay.
so there is a, yeah, that exists in the system today.
There's a bit of an overlap between cybersecurity vulnerabilities and vulnerabilities to malfunction that spread through similar kinds of, say, software updates and so forth. I do want to talk about that, but I want to just circle back real quick. We started talking about your career. I believe in 2012 you started to work for Boeing in their
Um,
aviation. Is that correct?
no, 2006.
Oh,
Yeah,
you were back
I
in
was,
2006.
yeah, since
At any
2000.
rate, you were there in 2012.
Yes, I was there in 20,
Um, and I think you were there until maybe 2014 or
right,
2015.
2014.
Oh, and so one of your colleagues was a fellow, a technical fellow named
Yes,
Terry Davis.
right.
And then he left and he joined a company in Virginia called Microsystems Automation Group that was tasked by the FAA in 2014 with writing an assessment of the state of civil aviation cyber vulnerability. It was called
Mhm.
Investigate Security Vulnerabilities for a Representative Aircraft. And this is not a secret document, but it's kind of buried in the archives. And Keeley, my colleague, who's been very helpful in doing research, uncovered this, and I was fascinating reading. I wanted to ask you, first of all, were you aware of Terry Davis's work on this document at the time that you were at Boeing? I'm sure it was very relevant to your work.
Right. So that's the reason we collaborated because we had the same interest of securing the aircraft. Terry was working with the Boeing Commercial Airplanes Division. I was with the Boeing Research Arm. And so we had the opportunity to work together on different types of projects. And I think we actually even co wrote a paper, a bunch of us co wrote a paper on the future E enabled aircraft security considerations, and that's where I got to know Terry very well.
And what was the kind of motivation for the FAA wanting Terry's group to do that assessment at that time?
I think it was mainly the fact is E-enabled aircraft. The objective was to have the special conditions, but the special conditions are temporary. They're not a permanent framework for the future aircraft models that are following that particular
Right.
787, for example. So they wanted a more holistic picture as to what issues should we look at strategically in the long term. And both Boeing, there are other people also who have worked the same to help address that area. And that's where I felt is there's a need to look 20 years and beyond. So we wrote a paper together at looking at a 20-year time frame as to these are the type of technology directions and these are the type of security issues that come and the mitigations that we need to do. Unfortunately, a lot of the security researchers forget the mitigations. They just try to attack the systems and say there's nothing, there's an issue.
So, I mean, I don't know if this is what you're referring to, but we do see press accounts of people saying, oh, I sat on a plane, I was able to hack into the in flight entertainment system, I was able to see these systems that weren't supposed to be attached to it. And it's interesting to know that, but that you're talking about mitigation, that's not a solution. That's not telling us, that's not giving us a holistic sense of what the potential issues are, and more importantly, what should we do about it?
Right. I think mitigations, I mean, are essentially directions that are considered to be solutions for the problems which are security threats.
Okay.
So, for example, ADSP, like I said, there's a whole integrity aspect, but there's also the privacy. Elon Jet is a classic example where the ADSP messages were used to track a person of interest and figure out where they are going. It's a problem that actually I raised to the FAA forum back in 2011 or 12, and it's something that can be mitigated. I mean, mitigated to the sense that it can be solved, but there's a need for it. The need
Right.
doesn't become apparent till actually the problem becomes very clear to the stakeholders. So that's what
Yeah.
I mean, that the community is ignoring the solutions. They are looking at just the problems. And I feel that is, we don't want to reinvent the wheel, right? It's like a problem that's circular.
Yeah, I mean, I've talked to some other cybersecurity researchers regarding aviation, and it does seem like as this paper dealt with, I mean, we have each generation of aircraft is becoming successively more
Right.
complex and interconnected. There's more surface area,
Yeah,
and it's the nature of the product that you can't just go and like buy. You can buy an iPhone and try to crack it, but
sure.
something like a 777, it's much more problematic. And as this paper says, any information that the FAA gets from Boeing about how this plane puts together is highly proprietary, not
Hmm.
to be shared. So it's a real challenge for security researchers to try to
It
grapple with what
is.
the nature of the potential
Yeah,
vulnerabilities are.
right. And I think that is completely right. I think it is, the fact of the matter is Boeing, I mean, any aircraft is got proprietary. That's the reason why it's a business. They have a secret sauce that is used to make the aircraft the way it is, which is efficient and performing the way it's required to.
My interest in MH370. I'm fascinated to ask you,
Hmm.
being at Boeing in 2014, in which and this incident occurred in which a plane diverted, something was done to its to an electronic system that is required a fair degree of sophistication. It starts transmitting these signals. I mean, at the time, did was that were potential red flags being raised by that?
So I had left before that happened. I
Okay.
was at University of Maryland at that point. But yes, it is a incident that still is a mystery. That I don't know. There are many theories to it, as you have explored. It's not something that you can. I think way back then, I was contacted by a journalist who wanted to investigate that angle, but I was not at Boeing, so I did not want to pursue that at that point of time
Okay.
and misattribute things. But I think it's still, there are many theories to that, but I think as you have explored in your documentary, I think with Pentest partners, they have shown the feasibility is very low, which means the risk is really going down to negligible for that attack vector, if I can say.
So pen test partners thought that the probability was low. Of course, the probability is either 0 or 1. Really, I mean, either can be done or it can't.
Right.
Todd Humphreys at the University of Texas thought that it's feasible, and that
Yeah.
therefore, given that we don't know what happened, um, one of the major points of contention has been there are some people who have sort of put themselves forward and said this is impossible without really explaining why. Um, and neither pen test partners nor Todd Humphreys said that it was impossible. Whether it's
Mhm.
something is difficult or not, I mean, I guess it should. Todd Humphreys' point was that, like, look, if this is not known to be impossible, then it should at least be explored.
Yeah, I completely. I think so. I have been wanting to. The only way to prove it is not possible is to show a penetration testing based study that shows the inability of attack vectors that are feasible from non unauthorized people on the
Right.
aircraft to try to do that. Then it's not possible, right? So that is requiring companies to come together, not just the airframer, but other suppliers too, to come together to make a penetration testing based study to disprove that a cyber issue led to this particular incident or possibly into this incident.
Right.
There is no other way to show it. What I know is that recently, as you know, GPS spoofing has been creating similar deviations that are unexpected by the pilot on the aircraft. So there is that possibility, but you know that the pilots are prepared to just get back the aircraft into its intended trajectory, but it's not. I'm saying that it's possible to do to that extent, but not really to the extent MH370 went into. So that,
Yeah, MH370 was a very particular case. It had a very unusual set of
mhm,
conditions that led to a potential vulnerability. One of the things that I thought was very interesting in the MSAG paper, the Davis paper, was they kind of looked at different aircraft and tried to assess the particular. They were looking at vulnerabilities in a very broad sense,
mhm,
like how is software updated, how is it
right,
uploaded, how is it confirmed, and it was interesting to look through the aircraft and look at the points of vulnerability. The 777 kind of was heads and shoulders above all the others, and I wanted
good,
to ask you a little bit about that.
yeah.
And I think it has to do with the fact that the 777 is really the first generation of fly-by-wire aircraft, and maybe people weren't thinking about cybersecurity as much in those days.
Right. I mean, it's true that it was more about enabling rather than securely enabling at that point of time, because the that threat requires the threat actor and the attack vector. So those were not really obvious, and hence there was not much consideration. With more e-enabling, which happened with the 787, there was a need to look at. When you say supply chain, there are two ways at least I think of. One is the software supply, because as you know, the aircraft has hundreds of suppliers, each have their own systems and their software systems which need to be updated as you go more and more. When you put more and more code, you need more and more updates, and that means you have to have a supply chain that delivers the software securely. The 787 was a classic example of a global supply chain that came together to put the aircraft together.
Mm-hmm.
It was not with the 777, but with the 787, they had to put the aircraft together from multiple suppliers. And hence, software also had to be delivered with the same um, globally spread network of suppliers, which means you have a software supply chain, you have a hardware supply chain, and you have a parts supply chain. There are different supply chains that come together for the aircraft. And so the software is what I think Terry's paper focused on, as to
Right.
supplying the software has to be all the way from the suppliers to the factory or to the airlines and then to the airport and then to the aircraft. There are multiple hops. And that's what we explored together at Boeing for the 787 initially, to look at the software distribution system and data distribution system and see how we can secure from the supplier all the way to the aircraft onboard system.
And
That
do you feel confident that that was? I mean, you took strong positive steps. I mean, it sounds like it seems like an overwhelming problem
it
to
is,
deal with.
yeah. So that's where, if you look at figure 3, I think, in the document, you'll see
Right.
that it comes down to essentially verifying the integrity. And that is what it is. Essentially, the integrity is the first critical property you need to verify. And that has to be repeated at multiple points of the distribution. If you look
Right.
at the physical analogy, it's like opening each container, making sure that the part is still there intact, and scanning it and sending on next. That's essentially what has to happen. So you can actually compartmentalize the problem to a specific function that has to be verified first that it works, and then put in multiple locations and maintained there.
So I sort of want to draw a line under the concept of supply chain security.
Mhm,
Um, Again, for people who might not be familiar with it, it has come to the fore very recently because Israeli Mossad apparently used a supply chain vulnerability to put bombs inside walkie-talkies and pagers used by Hamas.
mhm.
But this is a problem that has been of concern for a very long time. We tend to think of security in the sense of pre-existing things that are already out there in the world. You know, when you log on to your bank, you have to provide your password and so forth. And we try to think, well, what if I could fake my, what if I could run a machine that, generates thousands of passwords? I can break in that way. But this is a different way of accessing a system, and that's actually infiltrating the production or updating process to introduce some kind of malicious virus or to leave a backdoor that you can get into.
Right.
And this is something that you've been thinking about for a long time, but I think the public has only recently become aware of.
Right. And I think you can broaden it further. So there is a hardware, like I said, the recent incident with Lebanon, I think, is a hardware supply chain
Right.
that, and also the software. If you think of the enabling of the whole explosive is based on a, remote command execution that happens, and it is both software and hardware. But I think apart from that, there's also the supply in the context of what service providers are you relying on to be operational. And this can be, for example, someone providing you with electricity. That's a supply, right?
Right.
So they are also cyber enabled. You're relying on them for that. And so that is becoming a supply chain issue too. So there are three different ways, I think. One is the software, the hardware, and the service that you have to consider as your suppliers in any system today. Unfortunately, that's the reality of things. And they have all three got issues. So with the pandemic, your supply of services was disrupted, which led to you getting disrupted as well. With the recent the Lebanon attacks, your hardware and a little bit of software was also an issue in the supply chain context, if that makes sense.
One of the ideas that's important in aviation cybersecurity, I think, is the idea of you can sort of silo different systems so
Hmm.
that they can't interoperate, the degree to which they do interface is highly protected. And for instance, you will have what's called the in-flight entertainment system, where people can log on and get send their email and so forth. That
Yeah.
should be really firewalled from,
Mhm.
say, the computers that run the control surfaces, right?
Sure.
You
Yeah.
don't want a hacker in C27B to be
Right.
logging onto your in-flight entertainment system and taking control of the flight
Right.
surfaces.
Right. And I think I would say it should be highly assured. There's no way you can get 100% security, but there's high assurance that you can put at these critical points of segregation that you need to have in order to assure the aircraft is safe.
Right.
So, with the in flight entertainment system, the classic approach to this is having a one way airing 429 bus that goes to that particular system to just deliver the message about the flight position. So you can show it on the IFE systems on the cabin side. There is no way, two-way communication where you need to have an airing message taken to the aircraft. It is only to the IFE. And
I
so
see.
that's the one-way direction, a diode type of assurance that's given in that
Okay.
context.
So one of the idea has been expressed to me that historically in aviation cybersecurity, the idea has been that if you can sort of restrict access to a system, you need to be less um, sort of armored up against attack. I mean, you take something like an ATM, which is on a city street, it has to have lots of security. The password has to be, the
Yeah.
identification. You have to be sure who you're dealing with. If you have an AirInc 629 bus in the
Mhm.
electronics bay of a 777 that only certified people are going to be accessing,
Yeah.
you don't have to have it have. And my understanding is that the AirInc 629 bus does not have any layer of security in it.
Yeah, I think so. Recently, in April 2024, I organized Embry Riddle Aeronatical University, NASA, and National Science Foundation we had an aviation cybersecurity workshop here in Prescott, Arizona campus, and that issue came up as to access control to systems that are assumed to be inaccessible. How do you, in the modern world, anyone? I mean, there are stowaways in aircraft. There are insider problems that happen on the tarmac side. All of that happens. So, how do you now become resilient in this new age where you cannot assume it's inaccessible and you can just let go of security? So that was brought up as an issue and has to be dealt with either using camera based techniques or actually putting in layers of defense into the electronics themselves, which is kind of tricky because there's not
Mm.
much resources there. But at least to have that level of awareness in the community is making people rethink that assumption of physical security, that no one can access that system, so we can be okay with it. So that doesn't hold in the cyber physical resiliency world.
So one of the ideas that has been that I've come across is the idea that if you are a hacker of sufficient sophistication and you
Mhm.
are in possession of a piece of electronics,
Yeah,
you should be presumed to be able to make that piece of equipment do anything that it is physically capable of.
right. I think so. That's where the feasibility of it.
Right.
So that's where your threat actor and the threat vector come in. So if you have the suspicion that if you're going to operate in an area where it is possible for a highly sophisticated attacker to create something that is of concern, then your risk goes up. And
Right.
so that airline or the airport or the regulatory authority then becomes responsible to come together to solve that problem with some layers of defense into the
Right.
aircraft. We cannot necessarily do it for all of them. You don't need
Right.
to because it's an overkill. And so then it becomes really context driven, if that
I
makes
I
sense.
think that I think it's an important I think it's important to be aware of the mindset when dealing with security just broadly, that
Yeah,
you shouldn't assume that a system is secure because it seems like it would be really hard to hack. You should like
sure.
you were saying, just put a pin on it. You were saying that to be really confident that an attack cannot be made,
Mhm.
we would really need to organize a a gathering of all the people who would have all the necessary
Right.
knowledge and try to break it. See if you could
Yes.
break into it.
Yes, and that's what is happening in communities of aviation. Fortunately, now, Aviation ISAC is an example. It's a community of private and public stakeholders in aviation. And one of the activities is just looking at the threat intelligence that comes in and tries to understand what kind of threats are out there that we need to be concerned about. And
Right.
also, they have been open to having vendors share their product and have other pen testers test that product for security issues. So these are also happening as activities within the community where, as you know, airplanes are 40, 50-year-old machines that can keep going. And so you cannot assume risks is mitigated. They'll keep evolving and changing or actually escalating. Then you need to be able to deal with that continuously using such activities. Penetration testing is one of the common ones.
When I spoke to you before, one of the points I really wanted to get at with you was the idea of, as you say, like this is a dynamic process. It's not like there's one vulnerability which we need to patch. The technology is constantly evolving. The demands are constantly getting. People want more and more bandwidth. I just did a
Yeah,
piece about how people now have the SpaceX low Earth orbit
yeah,
satellite internet service.
yeah,
They want more, 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 more. In the olden days, the aviation was all about going further, faster,
yeah.
and you had, people could brag about how quickly they were going,
Hmm.
and we've actually moved backwards in the last, since the Concorde retired. We don't go half as fast as we used to go, but what we do have is internet, streaming video. We've got connectivity, and we have efficiency. We're much more efficient. The engines are more efficient, and so we have different goals now from what we used to. I've gone on a bit of a tangent here, but I guess the point I was trying to arrive at was that now that planes are so safe, they don't break. You know, we have one of the things that connectivity gives you is the ability to constantly monitor all of your systems, you know, automatically stream that data back to the maintenance hub. And so I've had pilots tell me that they're flying along over the Pacific and they get a call on um, ACAS that's saying, "Oh, you have to like your left engine is burning 3% more oil than it normally does, or
Okay.
whatever."
Okay.
And so this is great for safety. And so I think we've, and I don't know if it's like being too incautious to say that we've solved safety. Planes are incredibly safe, but but in getting to that safety, we've implemented systems that themselves have a kind of vulnerability that we haven't had to worry about. We're not in the habit of worrying about.
Yeah.
And so I think that the work that you're doing is important. And I think this GPS spoofing that you alluded to earlier has made people realize, wait a minute, these systems, which are incredibly useful, GPS is just so valuable for so many reasons, not accepting safety, but it also is a system that can be screwed with by a persistent threat actor.
Yeah. Yeah. I think you make valid point there that but I also want to mention that there are other things going on in terms of, making airplanes quicker. So
Okay.
there's a whole NASA project that looks at making it not just different. It's going to look like more like a Batmobile. It's going to be much faster.
Oh,
And so
the
there are,
brace trust wing is.
yeah, right. So there are exploratory where even at the airport they're trying to make the payload mobility much more efficient. So the goal ultimately of aviation is to have a point to point movement of payload in the most and in the quickest way. It's like
Right.
in the internet analogy, it would be like putting an Ethernet and just having just two countries communicate on just one network instead of waiting to go hop, 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 hop like that, right? So
Right.
that's the idea of aviation. It's still there, not maybe at the Concorde level, but they still want to make everything more efficient so things can move seamlessly.
Yeah,
But as
speed
you,
and efficiency go hand in hand. For instance, if
yeah,
you can route the planes
right,
directly from one airport to the other without having to go through various waypoints,
right.
etc.
Right, but then there is the whole society aspect where you have to respect the environmental constraints as well, and the those things. So there are multiple performance goals that you have to meet. Hence, there is a delay with the Concorde. Maybe they did not respect all of those. That's the reason probably the program was not sustained. But now there is a interest in make our a reignition of interest in trying to respect all of those and try to move forward faster. And
Yeah.
all of that is driven by technology. That's where the cyber dash physical system comes in, which is they all rely on cyberspace and
Hmm.
technologies that use cyberspace, which can enable them to do that. So with the engines, for example, you can only make a delta improvement in the performance by making it a different shape or different type of structure. But you can do a lot with software based advances, such as taking more data in, telling that, you can make it a little bit more efficient by making this setting here. So that is where the improvements are really coming in to make it faster. And like you said, there is the whole technology comes in, but then there's the other edge of that sword, which is the security issues, which is hard to convince for a person who's just trying to focus on making it faster and not necessarily. So it goes back to the whole Concord goals where they probably not consider environment and other things, sustainability or in general. They not consider that, and hence now they do not really considering security as much. And so there are gaps that need to be addressed, and that's true that we have to address those gaps. Continue to do research to bridge the gaps.
I mean, I do think that like I feel like I am in this fight in a way that's different from you, in that you are paving the way to understand the nature of the problem, and I'm sort of trying to pave the way for people to take it seriously, because none of this technology will be implemented if there isn't a sense of urgency.
Mhm.
Um, Traditionally, changes to the systemic changes have been made when planes crash,
Mhm.
or maybe when airlines go bankrupt, or when the public demands it. But if there's a big vulnerability that's just waiting to be exploited by a clever and malicious threat actor, um, it's hard to convince people to spend some money to address it, to mitigate it beforehand.
Yet, I think I do share the same concern as you have just expressed, which means convincing the stakeholders. And that is why we organized a workshop back in April where all the government, the private, and the academics came together to understand this new area. For them, it was academics are not necessarily as well versed with this area yet. Government people have their own opinion about it. So we have to bring all of them to kind of convince, hey, these cyber physical attacks, which you've not thought about, are a concern for the safety of the aircraft that you're trying to now regulate and advance. Um, that is what we are trying to do. And for that, there's no point just telling them the concern. I think you have to show case studies where we can say this is probably something you've not thought about. One example is electronic flight bag. That is one thing that how Leonardo DiCaprio carries a suitcase. No longer that is needed. It's more about a tablet that you carry. It's not connected to the avionics, but still it is making decision making and situational awareness for the pilots more and more. So what kind of risks come from that, and are they related to safety issues?
And so Ken
Those,
Monroe at Pentest Partners has done a lot of work with electronic
right,
flight bags and
right.
has sort of pointed out that risk. And of course, that is just one of many. We already talked about ADSB. There's
Mhm.
many other systems that are potentially. And I actually just also want to quickly shine a light on a term that you introduced me to, and that again a lot of people might not be familiar with: cyber physical,
Mhm.
which I think has to do with, I mean, people are familiar with the Internet of Things, the idea that the connectivity, the free flow of data through the wires of the world, they are connected to things. Ultimately, there's actuators and there's physical manifestations of these things. In the case of hacking into an airplane, it could be taking control of the flight surfaces,
Yeah,
or commanding. I mean, an enunciator that says pull up is a kind of physical system. Yeah.
right. Yeah, I mean, it is. So you bring the Internet of Things, for example, is a recent advance that aviation is trying to get into the aircraft more and more. So, as you know, lavatory is a traditional one where you have the smoke detectors, which are actually indicated to the pilots if there is a smoke in there. So, that is going to be more and more Internet enabled, those kind of actuators and sensors. So that is a whole new problem. So I have students working all of that to show what are the ways in which one could come in, and we need to show it to industry and to government both, because they work hand in hand. And if you convince only one person, the other person may not be as convinced. So there is a need to do IoT security. There's a need to do CNS. ATM is a general term. CNS is communication, navigation, surveillance with air traffic management on the ground. GPS is a classic navigation that comes into that CNS ATM. ADSP, the surveillance. Communications is ACARS. All of that are also technologies that are not necessarily secure. They have to be looked at for whatever assumptions were made, they have to be looked at and revisited to convince people that we need to look at it more seriously. And that is what we have been doing here. We call it as capture the flag. I don't know if you heard the term, but it's a cyber competition that is something I have my students develop challenges that are cyber physical in nature, and we take it in person to different venues that are happening in the year. And DEF CON is one of them. There's Aviation ISAC Summit. There is a rodeo, cyber rodeo is what they call it, for the Aviation Cyber Initiative. All of those venues, professionals and government and academics and others come, and they will look at it and get, oh, this is something we've not thought about. Let's discuss this more. So that's where we kind of, at this point, trying to do is to raise awareness of that topic of cyber physical security, if I
And do
can
you
say.
find when you talk to airlines or the government regulators, the FAA, EAA, do you find a receptive audience, or it sounds like it can be challenging? More, maybe some people are more receptive than others.
Yeah, I think it's recently been easier to convince them. I think the I would say, Stuxnet was kind of a revealing a moment for people, epiphany kind of, oh, this is possible. Let's not try to
We
get
can
this
use
on
software
aircraft.
essentially to destroy the
Right,
centrifuges of the Iranian nuclear
right,
program by
right,
putting in malicious software that messes up the functioning of these centrifuges to destroy them
right.
and set the
Yes.
Iranian nuclear program back by years, I guess.
Yep. Yeah. So that is a physical system which was thought to be uh, fine, but this Mission Impossible type of scenario where everything is fine is what the operators saw, but it was actually disrupting on the back end of that physical system. So that kind of was a epiphany, that the moment that where people said, okay, let's consider cyber physical a little bit more seriously. And then recent GPS spoofing has made it even more clear. Before that, actually, we were taking people into a flight simulator and showing them, look, what if your navigation database has bad waypoints and the pilot is in low visibility? There are multiple things you need to have a threat scenario. And so we were
Mm.
showing all of this to people to raise awareness. And you have to do it at different levels. And I think in the recent few months, I would say it's been easier to make people understand we need to think of cyber physical resiliency, because we can no longer trust all these cyber enabled systems that are behind our.
It's an unfortunate aspect of aviation history that people solve problems after the problems kill people. And so I would like to the extent that we can avoid that first step, would be
Yeah.
nice.
But I think, to be honest about the last 20 years or so that I've been working this, I feel for the security community within the industry and in the government, they have been looking at cybersecurity, not cyber physical, because you can't solve them all. But they have looked at how do we at least protect the software that is uploaded. It may not be the most efficient way to do it. For example, your computers get updated on their own. You just have to say auto. With the airplane, it cannot. You have to have a process that takes one step and then next and then next. It's slow, but it still works, at least from a safety viewpoint. So they have taken at least that much of steps. But as you know, the threat environment keeps evolving. So you have to be able to do it at a speed that probably aviation is not used to. So I feel they're not waiting for an incident. They have been putting more and more money. It's just that the threat surface is so huge that it is not easy. I mean, in the weather sense, for example, you can look at turbulence and you can look at bad weather. How do you navigate those two? But in the case of cyber, there's so many threat vectors that is very difficult to do without the right experts in there. So that's the challenge that the industry is facing, if I can say right
I
now.
feel like we're really on the cutting edge here. This really hasn't been written up about very much. I'm very excited. I'm actually going to pitch more articles about this because I feel like it is really potentially important. Krishna, I want to thank you for taking the time. I've been trying to get you on the show for a long time and you've been very busy. I'm very grateful to you for sharing your time and your
Thank you.
expertise. I would love to keep talking to you about this.
Yeah.
You're going to be doing amazing work going forward and I would really love to be at the I look forward to hearing about it.
Yeah, I'll be in touch with you. Thanks for the opportunity. It's been wonderful
Okay.
talking.
I want to thank Dr. Sampigethaya again for sharing his time and expertise with us. He brought us a bunch of really interesting points. The main takeaway for me is that the attack surface for aviation cybersecurity is vast. The threat is ever evolving. Key shareholders in aviation are taking it seriously and are continuing to adapt. But there are no perfect fixes. And the more the industry takes the threat seriously, the less likely that it will be caught off guard. As with Stuxnet, there are always going to be vulnerabilities to exploit for threat actors who have the resources and the determination to find them. Could past cyber physical targets have included MH370? As Dr. Sampigethaya says, there's no way to know right now, and finding out would take a comprehensive, detailed penetration test involving Boeing and key suppliers. To me, that's something that is not inconceivable. All right, that's all I have for you today. From now, this is Jeff Wise saying don't stop looking and don't stop asking hard questions. See you next time.